आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
The fascinating procedure of penetrating through layers of human skin to display the bones and soft tissues within like a monochromatic picture skew is an usual routine in hospitals. In fact, radiograph, or commonly called X-rays, are only one among a spectrum of diagnostic tools. Influencing an estimated 70% of healthcare decisions, diagnostic tests play an invaluable role in mitigating diseases worldwide. Diagnostic techniques used in human healthcare are classified as either in vivo, which includes the use of devices such as stethoscopes, blood pressure devices, or ultrasounds, or in vitro, such as biochemical, pathology, or microbiology tests. In vitro diagnostics medical devices, that is, IVD, are tests used on biological samples such as tissues, blood, or urine to determine the status of a person's health. There is a broad range of IVDs from self-test for pregnancy and blood glucose monitors for diabetics to sophisticated diagnosis performed in clinical laboratories. As your brain starts to visualize people in white coats peering through a microscope and witnessing vivid colors of minuscule organisms, we shall as well add a narrative voice to your picture as we meet the scientist of the episode, specializing in vitro diagnostic devices. Dr. Manoj Gopi, Scientist E, Sri Chitra Tirunal Institute for Medical Sciences and Technology, Trivandrum. You're listening to Vigyan Ki Awaaz podcast, catalyzed and supported by the National Council for Science and Technology Communication as a part of STEM popularization, produced by Media for Community Foundation, content support by Kadalosai FM 90.4 Community Radio, and hosted by yours, Surya Kiran. Dr. Manoj Gopi, a brief introduction about his areas of research.
My name is Dr. Manoj, working in Sri Chitra in the Medical Device Development Department. So my background is PhD in genetics. So I will be working in the area of in vitro diagnostics to develop assays for disease prognosis, diagnosis, as well as for the therapeutic applications. So this is what my current research area. And most of the research will be doing for the assay development, especially in current scenario. The diagnosis is a key important area, and we need to do lot many diagnoses to identify the patients with the disease symptoms, as well as what is the kind of diseases. So for example, this in vitro diagnostics is a kind of area wherein we used to take biological samples from the patients, especially like blood sample or saliva samples or urine samples from the patients, and we will use this biological samples for profiling the diagnosis. That is called in vitro diagnosis. In our lab, we will be using different biomarkers for profiling the diagnosis, especially in communicable diseases as well as non-communicable diseases. So this is what one area which is we are focused on. In vitro is nothing like you will be taking the samples from the patients and doing the diagnosis. That is called in vitro diagnostics. That is what in a single sentence it means. So when you approach a doctor for their diagnosis, they will ask you to give the blood samples, for example. So you need to give blood sample, and the samples will be taken to the lab, and from the blood sample they will do the assay, and they will diagnose what kind of disease you are. Then the doctor can treat yourself.
Different health conditions can cause the same symptoms. For example, fatigue can be a symptom of anemia as well as sleeping disorder. So, a proper diagnosis is important when it comes to choosing the right treatment. At times, Even the drug that works on a pathogen may not work on a different variant of the same pathogen. Conclusively, acknowledging the importance of diagnosis and various diagnosing kits, let's learn about the use of these diagnostics devices on a common man or the nation as a whole, as spoken by Dr. Manoj Gopi.
Especially in the medical field like therapeutics, the diagnosis is a key factor. When you properly diagnose a patient, then only doctor can give an accurate treatment to the patients. Otherwise, it will be misleading to the patient for giving the accurate kind of therapies. If you say, for example, lot of diseases currently, if you see COVID came with lot many variants. Suppose if you see viral infection, almost the symptoms are almost similar. So in order to screen these kind of patients, you need to take the biological samples and you need to test with the biological samples in the lab, and you need to do the assay, and finally you will find that this is infected with COVID. Then only doctor can give a particular treatment of COVID. Otherwise it will be giving to some random viral disease. It will be predicted as a random viral disease. It is not particular to the COVID disease. This is case as an example.
Sir, can you give us an account of the changing landscape of this research as in the past, present and the future?
Earlier, it was like a symptomatic prediction of diseases in the previous days. Whereas the coming days, we will be getting lot of diagnosis we will be taking the samples to the lab and doing the testing. In future, what is happening is like there will be a point of care diagnosis will be coming. Point of care in the sense doctor can immediately take the samples in a single prick, and you can do a testing in a smaller devices with a technology called microfluidics, nanotechnology, and many other technologies came up for random screening of diseases, so that doctor can immediately diagnose the patient at the table itself, and they can make the decisions. By further delays, they can go for the therapeutic applications.
You're listening to Vigyan Ki Awaaz podcast as a STEM popularization initiative catalyzed and supported by the National Council for Science and Technology Communication, produced by Media for Community Foundation, content support by Kadalosai FM 90.4 Community Radio, and hosted by yours, Surya Kiran. Moving ahead, let's hear from Dr. Manoj Gopi on where India stands in the ranking of these research areas.
Currently, India is in the faster growth of IVD, and especially in the infectious disease segment as well as non-communicable disease segment. We are marching ahead with the technologies like we are working on point of care technologies, where India is nowadays manufacturing lot many point of care technologies where doctor can easily diagnose the patients.
Now, sir, can you please tell us about our contemporaries or competitions in this field?
See, these are kind of multiple technologies are involved for developing a single kind of IVD technique. So if you see, we have a lot of collaborative institutes are working on different kinds of making this technology viable for the societies. So not a single institute can make these kind of technologies, but we need to have a collaboration with the multiple institutes to make this technologies are viable. So if you say all the teams should work together for the progress of these kind of technologies at the earliest to put the market. So especially US is having a lot of technologies which they are into the IVD segment, they are putting into the market actually. So we are trying to we are trying to make that technologies available in India as well. So that technologies we will trying to make in India, and we are trying to reproduce in India to make that technology feasible for Indian populations as well, because most of the time the technology which is available around the globe cannot work in the Indian scenario. So we need to make our own technology with the kind of solutions available across the world should be used in India, and also it should validate properly in the Indian subset of population before launching these kind of products.
Can you brief us about how Indian industries are associating with your research projects?
we have lot many industries, especially in the Kerala region as well as in the Pan-India region. They are associated with us for the collaborative development of project, and also we will be developing the technology of in vitro diagnostics, and also we will be transferring them through the licensing through our institute SCTIMST. And most of the statement, which is the problem statements, are we are receiving from the industry for solving their challenges, what is there associated with the challenges, and what are the newer technologies which we can offer them for the better development of their IVD technologies, so that they can make much easier diagnosis or the predictions for that patient can give much better results.
Interesting. Can you give us an account of your patents, research papers, and the awards you have won?
Patents, basically in the COVID segment we have done technologies, and I have 2 patents in the infectious diseases as well as in the non-communicable diseases. These are all filed patents. Currently, including my PhD, I have around 20 international publications, especially in the area of IVD, especially in the diagnosis segment. So I started my career with gastric cancer diagnosis. Now currently I was into non-communicable diseases, especially in the cardiac segment areas. That is what I am currently focused on. Yeah, actually, I was before joining with the Chitra, I was in an industry where I was working on the IVD. I got an award for the better performance in the R&D output, especially for translating the IVD technologies to the industry, as well as for the manufacturing and marketing of these technologies.
Thank you, Dr. Manoj Gopi, for patiently spending your time with us and sharing your researches in the landscape of in vitro diagnostics. Conclusively, would you like to say anything in Vigyan Ki Awaaz podcast as an initiative to take Indian research stories to the common crowd?
I would like to acknowledge DST, and I'll be very thankful to DST team for giving me the opportunity for speaking about my research area and introduction about what is IVD and which will be beneficial for the societies. Thank you very much.
The Department of Medical Devices Engineering, under the Biomedical Technology Wing of Sri Chitra Tirunal Institute for Medical Sciences and Technology, Trivandrum, focuses on the research and development of medical devices, covering the entire life cycle from conceptualization to technology transfer, including empirical design, computer-aided modeling, in silico evaluation, fabrication, prototyping, and functional evaluation. The department has 6 divisions, 4 of which established their own domains of medical devices development, while the other 2 strongly support the device development activities in terms of precision fabrication of prototype devices and developing animal models for preclinical evaluation. You're listening to Vigyan Ki Awaaz podcast, catalyzed and supported by the National Council for Science and Technology Communication, produced by Media for Community Foundation, content support by Kadalose FM 90.4 Community Radio, and hosted by yours, Surya Kiran. We will meet again in another episode of equally fascinating research story. Until then, take care. Thank you for listening.